Okay, we're ready to practice hypothesis testing for the proportion. So let's recall this paying for music downloads question. We did a confidence interval for this question last week. By last week, I mean in the previous chapter. So there was a survey. The survey asked people, do you pay for your music downloads? So they surveyed about 1,003 people. 506 said that they actually do pay for music. Okay, here's our 90% confidence interval that we did in the last chapter. So our question, can we conclude that the proportion of adults that pay for music is different from 50%? Okay, so let's read this a little more closely. Can we conclude that the proportion of adults that pay for music is different from 50% at the alpha 0.01 level of significance? So notice we're being asked different from 50%. So different from, that should cue us that that is a two-sided test. So let's start with our hypotheses. So I like to start with the null or alternative hypothesis. So I'm going to say pi not equal to 0.5 because we're being asked, is it different from 50%? Different could be less than or greater than. So that's a two-sided test. Therefore, my null hypothesis is pi equal to 0.5. So this is a two-sided test. Okay, let's get our information. So number of successes, that's people who pay for music, that is 506. Our sample size is 1,003, and so our estimate P is 506 over 1,003, which is equal to 0.504. We were told that alpha is 0.1, but this is a two-sided test, right? Two-sided test, so we're going to divide alpha in half, so alpha over 2 would be 0.05, and therefore we're going to need our critical value of z, so z.05 is equal to 1.645. Okay, step 2, we calculate our test statistic. So this is for proportion, so we have our new test statistic, z-stat, and it is equal to p minus pi naught over pi naught, 1 minus pi naught over n, take the square root of that. So let's plug in. So our estimate for p was 0.504 for p, and then for pi naught, it will be 0.5, and then n here is 1,003. So let's go ahead and plug in. So we have 0.504 minus 0.5 divided by, so 0.5, 1 minus 0.5 divided by 1,003. Take the square root of that. So I get 0.004 over 0.016. Put that into my calculator. I get a value of 0.25. Okay. 3. Rejection region. So we recall that rejection region follows from the alternative hypothesis. This is two-sided. Therefore, we're going to have two ranges for our rejection region. So that'll be z-stat less than negative z 0.05, or if z-stat is greater than positive z 0.05. So that would be z-stat less than negative 1.645, right? Where negative z.05, so we found that to be 1.645. Or z-stat bigger than positive 1.645. Okay, so 4, we're now ready to make our conclusion. Okay, so we just plug in our test statistic into the rejection region and make a decision. So our z-stat is equal to 0.25. Is 0.25 less than negative 1.645? No, it's not. So it's not in that rejection region. How about over here? Is 0.25 bigger than 1.645? Well, no, it's not. So it's not in that rejection either. Rejection region, rather. So since z-stat, actually, I'll write this a little differently. I'll say because z-stat, since it's not in either of these regions, in fact, it's in between. So because negative 1.645 is less than 0.25 is less than 1.645, right? It's not in either rejection region. Therefore, we fail to reject H naught. Okay, step 5, interpretation. So we would say there is not enough evidence to conclude that the proportion of Americans that pay for music is different from 0.5 at the alpha equals 0.1 level of significance. Okay, so we finished our hypothesis test, but let's go ahead and practice our p-value approach. So let's just say p-value approach. So steps 1 and 2 are the same. So 1 and 2 are the same. Step 3, we need to calculate the p-value. So this is going to be equal to 2 times probability z bigger than z stat. Right? I'm multiplying by 2 because this is a two-sided test. So plugging in equals 2 times the probability that z is bigger than 0.25. Okay, well, if I were to find this, terrible plot, but whatever, 0.25. So if we looked up this area in our table, we would find it to be 0.4. So therefore, this will be equal to 2 times 0.4 is 0.8. Okay, so now let's make a conclusion. We already know what the conclusion is because we know that the critical value and p-value approach are equivalent, but let's go ahead and do this anyway. So the p-value is equal to 0.8, which is bigger than 0.1, which is our alpha. Therefore, fail to reject H naught. And then our conclusion would be the same. Okay, last thing I want to do is let's make a comparison with our 90% confidence interval. So from 0.478 to 0.53. Okay, so 90% confidence interval. So notice that 1 minus 0.9 is 0.1, which is our alpha. So our alpha in this confidence interval is the same as the alpha in this hypothesis test. So the 90% confidence interval was 0.478 to 0.53. And let's just note that 0.5 is in this interval. Hence, 0.5 is a plausible value for pi. And so this agrees with our hypothesis test. Right, our hypothesis test said we failed to reject that the population was equal to 0.5. Well, whenever we did a confidence interval, 0.5 was in our interval. So 0.5 was a plausible value for the proportion. And so it makes sense that we failed to reject the null hypothesis, which said that the proportion was equal to 0.5. So we can see the connection between confidence intervals and hypothesis testing. Okay, so another example, same, we did this example last week as well when we created a confidence interval. And let's see, let's recall. All right, so Minneapolis Star Tribune reported that 73% of Americans think Starbucks is overpriced. It was a sample of 1,000 people. So is there evidence to conclude that the proportion of Americans that think Starbucks is overpriced is greater than 0.7 at the alpha 0.05 level of significance? Okay, so I recommend pausing the video, seeing if you can work through this one by yourself, and then watch me work through it. Okay, so we see that P was equal to 0.73, N here is 1,000, and alpha is 0.05. Okay, so what are we being asked? Can we conclude that the proportion of Americans that think Starbucks is overpriced is greater than 0.7? So greater than 0.7. So this is going to be a one-sided test. So I'm going to start with the alternative because that's our question of interest. So we are asking, do we think that the true proportion is greater than 0.7? And therefore, our alternative will be less than or equal to 0.7. Two, test statistic. So we know it's z-stat equal to, so p is 0.73 minus pi naught is 0.7 divided by, so we have 0.7, 1 minus 0.7, and here is 1,000. We will take the square root of that. So we get a 0.03 in the numerator and a 0.014 in the denominator. And so I get a value of 2.14. Okay, rejection region. Okay, well, this is one-sided, right? This is a one-sided test. So I'm not going to divide alpha in half, and so we're going to need z.05, which we used in the prior problem, 1.645. So our rejection region, which will follow from the alternative hypothesis, which was pi greater than 0.7. So that means our rejection region will be z-stat greater than 1.645, right? Because this was greater than, this is greater than. And if this is greater than, this is positive. It's either greater than a positive or less than a negative. And here, I'll even, right, this was z stat bigger than z.05. Okay, conclusion. So let's plug z-stat into our rejection region. So our z-stat is equal to 2.14, which is greater than 1.645, which is equal to z.05. Right, I just plugged 2.14 in for here because that's our z-stat. 2.14 is indeed bigger than 1.645, therefore it's in our rejection region. And if it's in our rejection region, that means our conclusion is reject H naught, accept HA. So interpreting this, we would say there is enough evidence to conclude that the proportion of Americans that think Starbucks is overpriced is significantly greater than 0.7 at the alpha equals 0.05 level of significance. Okay, but as before, let's do the p-value method as well. So we know that steps 1 and 2 are going to be the same. Step 3, so the p-value will be equal to the probability that z bigger than the absolute value of z star. Right, we're not going to multiply by 2 here, right? No 2 here because this is one-sided. So this is the probability z bigger than z stat, which we found to be 2.14. So z bigger than 2.14. So let's draw this. So 2.14. So what's this area equal to? So if we were to look that up, this is 0.0162. Okay, so let's do the conclusion. So our p-value is equal to 0.0162, which is less than 0.05, which is our alpha. So if p-value is less than alpha, we reject H naught, accept HA. And then interpretation is the same as before. Okay, and that wraps up all of the material for Chapter 9.